So now in this video we're going to come back to the fixed resistor voltage divider. If you have two equal value resistors, you put them across a power supply, you're going to have half of the voltage right where they connect between the resistors there. So this is just a signal voltage though. You can't power something that needs any real current because the voltage will drop. As you can see here, we have the fixed resistors up there, two of them. Same thing here, but now we're going to the anode, the long lead of the LED, short lead the cathode, to a 220 ohm resistor. Same resistor that is limiting current for that LED. Problem is, the voltage divider's also limiting current. It has to be able to provide the power, but I'm using all 10 kilo ohm resistors, and not much current can flow through them. They're somewhat high value resistors when it comes to the current you need for an LED. So down here we also have the voltage set, and we're using a transistor to transfer the voltage. So now that's not perfect either, but by far better, as you can see right there with the example. So here I have a couple pictorials. We need to make an emitter follower if we're going to use a bipolar junction transistor to transfer a voltage. So this is an NPN bipolar junction transistor. The arrow is pointing out. Some people say NPN not pointing in when it comes to the arrow. So in any case, we got 5 volts set at the base. So now really no current, I mean a little trickle, but very little currents flowing from base to emitter. So the voltage is going to hold really well at our voltage divider. And the transistor takes that tiny bit of current, lets a whole lot more current flow through, but it will only let enough current to flow through to build up the voltage there, but it's minus about 0.6 volts because from base to emitter is a diode, and so you lose about 0.6, 0.7 volts from base to emitter. So in any case, we transfer that voltage minus the drop though, so since we set it to 5 volts, we're going to have about 4.4 volts. And here's a pictorial, just in case it's a little easier to see than what you see on the board. I turn the transistor that way. You got to get used to being able to build stuff in a different order than what you see drawn. Usually it's drawn in a way that makes it easy to draw. It may not look as good on the breadboard. But in case, we got our voltage divider here. So 10 volts across the two resistors, 5 volts to the base of the transistor. That is the collector. You can see the pin layout down here. If you're looking at the flat side of the transistor, the left pin is the emitter, middle pin is the base, and the right pin's the collector. So we swiveled it that way and moved it over there, collector on top. So it's important that the collector is to the supply and the emitter is down there. The base to emitter, how much current is flowing through them, determines how much current flows from collector to emitter. And so we got the emitter, and then a 220 ohm resistor, long lead, the anode of the LED, short lead, the cathode to ground, right there. Remember, you got to put LEDs in the right direction. So again, it's a little odd to put the ground to the left, but generally speaking, when you draw these, you draw what's easier to draw. So here we are, a little closer on the board. You can see voltage divider directly to the LED. May not even look like it's on, but there you can see a slight glow right there. So practically all the voltage is being lost. There's about 2 volts built up though, because that's how much it takes for the LED to conduct. So it's building up a little bit. We'll look at that coming up. Here again, 10 kilo ohm voltage divider to get half the supply voltage to the base, the middle pin of the transistor. And so there you can see we got the flat side there. And so collector on top, or flat side to the right I should say. Collector on top to the positive supply, base, the middle pin to the signal voltage there. And then the bottom pin, the emitter, we got coming to the LED. And we will zoom back and look at those voltages. So I have the oscilloscope there, my power oscilloscope. I have the power supply set to just a speck above 10 volts because a little bit of voltage gets lost along the way. So that'll help get it to 10. I only have 8 squares, so we can't really use this oscilloscope to look at the supply voltage. Our voltages are all going to be in relationship to ground. If we look at the supply voltage, it goes off the screen right there, all the way up. So let's there we go, much better. And so we'll go up to this voltage divider, and there you can see we got that 5 volts right there. Pretty nice. Now we'll go to the circuit with the LED and its protective resistor. So that's the vast majority of the voltage is across the LED. If we go across the resistor, which remember sets the current, there's almost no voltage across the resistor. There's a little bit. So we're losing too much current from our voltage divider there. And we come back, if I yank the LED, you can see it jumps up. So it's that current path that is pulling it down. Now we come over to the transistor circuit, and there you can see we got 5 volts as far as the voltage divider is concerned. So it's holding its 5 volts. Now we come to the emitter of the transistor, and there you can see, looks like maybe we're losing closer to about 0.7 volts, it looks like. But it's pretty close to about 0.6 volts that we are losing from the 5 volts that we are given as a signal there. Once I get that in the board. There you go. So just a shy bit below 5, not bad though, and then a little bit above 4 right there. So you do lose a little bit of voltage, but that's pretty steady even as the load changes. That voltage will hold pretty steady there. The transistor will hold it. So in any case, hope that all made sense. Hope you enjoyed the video. Make sure you check out one of the other videos I'm posting to the screen. Click like, subscribe, the bell, all that. Donate to Patreon if you can. That helps out the most, but just watching videos helps out a ton. Thanks to everybody that does that. I'll see ya in the next video.